This is Sravanthi, working as Assistant Professor of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss Engineering Chemistry, Module 1, Electrochemistry and Corrosion. So in this electrochemistry, I am going to discuss topics are Introduction to Electrochemistry, Electrochemical Cell or Galvanic Cell, Cell Notation, that means how to represent a Galvanic Cell, and also discuss the difference between Electrolytic Cell and Electrochemical Cell. These are the topics today I am going to discuss in this class. So, electrochemistry. So, what is the meaning of electrochemistry? It is a branch of chemistry. It explains mainly the interconversions of electrical energy and chemical energy. So, electrochemistry is a branch of chemistry. It explains mainly the interconversions of electrical energy and chemical energy. So, these interconversions are two types. The conversion of electrical energy into chemical energy is called electrolytic cell. The conversion of electrical energy into chemical energy is called electrolytic cell. Whereas the conversion of chemical energy into electrical energy, chemical energy into electrical energy is called electrochemical cell or galvanic cell. It is also called as voltaic cell. So first we discuss what is electrolysis. Electrolysis means decomposition of electrolyte by passing electricity. Decomposition of electrolyte by passing electricity through the solution is called electrolysis. For example, here in this beaker we are taking NaCl solution. So when we pass electricity through this solution, so this NaCl decomposed into Na plus and Cl minus. So this process called electrolysis. So decomposition of electrolyte by passing electricity through this solution is called electrolysis. So this electrolyte, that what is the meaning of electrolyte? Generally these electrolytes are two types, strong electrolytes, weak electrolytes. So strong electrolytes means these electrolytes are, that means these molecules are completely ionized. Even at low concentration also, these ions are completely ionized, is called strong electrolytes. For example, in this, all strong acids, for example, HCl, H2SO4, HNO3. So these are the strong electrolytes, strong acids, all are the best example of strong electrolytes, and weak bases also. These are the example of weak electrolytes. So now let's discuss the decomposition of electrolyte by passing electricity. This process is called electrolysis. In this we discuss electrolytes. Electrolytes are generally two types, strong electrolytes, weak electrolytes. Strong electrolytes means these ions are completely ionized. Even at low concentration also, these molecules are completely ionized. That is called strong electrolytes. Best example, strong acids like HCl, HNO3, H2SO4, like that. All strong bases also like NaOH, KOH. So these all are the strong electrolytes. So these are completely ionized even at low concentration also. So weak electrolytes means these ions are not completely ionized. Even at high concentration also, these ions are not completely ionized or partially ionized, is called weak electrolytes. Best example, weak acids like acetic acid, propanoic acid, weak bases, ammonium hydroxide. So these are the weak electrolytes. So these are not completely ionized even at high concentration also, or otherwise partially ionized. So when we are using these electrolytes, we are passing the electricity through this electrolyte solution. So during this process, these electrolytes are decomposed. Like for example, we are taking NaCl solution in this beaker. So when we are passing electricity in this NaCl solution, so this NaCl is decomposed into Na plus and Cl minus ions. So this process is called electrolysis. Now let's discuss electrode. So what is the meaning of electrode? Electrode is a material or metallic rod which conduct electrons, which conduct electricity, is called electrode. So electrode is a metal or metallic rod which conduct electrons, is called electrode. So these electrodes are generally two types. One is anode, another one is cathode. Anode means it is a electrode. At anodic area, oxidation reactions takes place. So it is a electrode at which oxidation reactions occurs at anodic area. So oxidation means loss of electrons. Oxidation means loss of electrons. So now discuss. So loss of electrons, that is called oxidation reaction. So this oxidation reactions always takes place at anodic area. So anode is a metal or metallic rod which conduct electrons. Okay. So now coming to the cathode. So cathode also it is a electrode at which reduction reactions takes place. Reduction means gain of electrons. Gain of electrons. So this anode and cathode are the electrodes at which oxidation and reduction reactions takes place. For example, in zinc and copper. So zinc always acts as anode. Copper always acts as cathode according to electrochemical series. So zinc, it undergoes oxidation. So just now we discussed oxidation means loss of electrons. So copper acts as cathode. It undergoes reduction. Reduction means gain of electrons. So these are the electrodes. So just now already we discussed there are two types of cells are there. One is electrolytic cell and then one is electrochemical cell. So what is the meaning of electrolytic cell? So electrolytic cell means conversion of electrical energy into chemical energy is called electrolytic cell. Conversion of electrical energy into chemical energy is called electrolytic cell. For example, here in this diagram, we are taking, for example, in this NaCl solution. Molten NaCl solution taken as an electrolyte in this beaker. We place two electrodes. One is acts as anode and the other one is acts as cathode. And most important thing is in this electrolytic cell, anode is having positive charge and cathode is having negative charge. So when we dipped in these two electrodes in this electrolytic cell and we passed electricity through this, so this Cl is decomposed into Na plus and Cl minus ions. Na plus and Cl minus ions during electrolysis. So these ions move to the opposite charged electrodes. That means, for example, in this electrolytic cell, anode is having positive charge, cathode is having negative charge. So during electrolysis process, that means when we pass the electricity in this electrolyte solution, this NaCl is decomposed into Na plus and Cl minus ions. So these Na plus ions move to the cathodic area. Why? Because cathode is having negative charge in this electrolytic cell. So already we discussed this ions move to the opposite charged electrodes. That's why this Na plus ions move to the cathodic area and the Cl minus ions move to the anodic area. So what are the reactions takes place? So at cathodic area, at first NaCl, it is decomposed into Na plus and Cl minus ions. Okay. So during electrolysis process, starting when we passed electricity in this solution, NaCl decomposed into Na plus and Cl minus ions. So at cathodic area, which one undergoes at cathodic area? Sodium. So Na plus. So at cathodic area already we know that reduction reactions takes place. Reduction means gain of electrons. So at gain of electron, then deposited there as sodium. This is cathodic reaction. Reduction reaction takes place at cathodic area. So sodium gain of electron, then deposited there as sodium. And next at anodic area, chlorine moves to the anodic area. So already we know that at anodic area, oxidation reactions takes place. Oxidation means loss of electrons. So chlorine undergoes oxidation, then gives chlorine and loss of electrons. So here we are writing Cl2. So generally chlorine exists in a diatomic gas. That's why we are writing here chlorine gas. But here taking only one chlorine. So that's why we are writing here half Cl2. Only one chlorine involved. That's why we are writing half Cl2. So what is the overall reaction with anode and cathodic area? So sodium plus and Cl minus, it gives rise Na plus and half Cl2. This is the overall reaction during electrolysis process in this electrolytic cell. So simply with this, electrolytic cell means conversion of electrical energy into chemical energy is called electrolytic cell. So during this electrolytic cell, during electrolysis process, when we pass electricity through this NaCl solution, for example here, NaCl taken as electrolyte solution. So when we pass electricity through this solution, this NaCl is decomposed into Na plus and Cl minus ions. Okay, next at cathodic area. So when we place these two electrodes in this electrolyte solution, one is acts as anode, another one is acts as cathode. Anode is having positive charge, cathode is having negative charge. So during electrolysis process starting, this sodium chloride decomposed into sodium plus and chlorine minus ions. These ions are moved to the opposite charged electrodes. So for example, in this cathode, so sodium, it moves to the cathodic area. So cathodic area, already we know that reduction reactions takes place. So at cathodic area, sodium gain of electron, then deposited there as sodium. And next coming to the anodic area. So chlorine is moved to the anodic area. Why? Because anode is having negative charge, so positive charge. So anion is moved to the anodic area. So chlorine undergoes oxidation. Oxidation means loss of electrons, then gives half Cl2. Why you are writing half Cl2? Because chlorine exists in diatomic gas. So you are writing chlorine Cl2, but here involve one chlorine. That's why you are writing half Cl2. So overall reaction in this, sodium plus Cl minus, finally it gives Na plus half Cl2. This is the reaction takes place in this electrolytic cell. Now we'll discuss electrochemical cell. Electrochemical cells means which are entirely different from electrolytic cell. Already we know that. Why? Because electrolytic cells are electrical energy converts into chemical energy. But in this electrochemical cell, chemical energy converts into electrical energy. That is the main difference between electrolytic cell and electrochemical cells. These cells are also called as galvanic cell or voltaic cell. So what is the meaning of electrochemical cell? Conversion of chemical energy into electrical energy is called electrochemical cell or galvanic cell. So in this galvanic cells are electrochemical cells in which the electrons transfer due to redox reaction. Redox reaction means both oxidation and reduction reactions takes place. So already we know oxidation means loss of electrons, reduction means gain of electrons. So here the electrons transfer due to redox reaction and converted into electrical energy. So the best example of electrochemical cells are Daniell cell. Now discuss how to construct Daniell cell. So Daniell cell is the best example of galvanic cell or electrochemical cell. So it consists of two electrodes. One is zinc and the other one is copper. So already we know that zinc always acts as anode, copper acts as cathode according to electrochemical series. So in this Daniell cell, it consists of two electrodes, zinc and copper. Zinc electrode dipped in zinc sulfate solution and copper electrode dipped in copper sulfate solution, for example. So here, this is a zinc electrode and this is a copper electrode. So zinc electrode dipped in zinc sulfate solution and copper electrode dipped in copper sulfate solution. That means, for example, here we are taking two beakers. In this first beaker we are filling zinc sulfate solution and in this beaker we are taking copper sulfate solution. Okay, zinc electrode dipped in zinc sulfate solution and copper electrode dipped in copper sulfate solution. So zinc rod. Okay, zinc electrode dipped in zinc sulfate solution, copper electrode dipped in copper sulfate solution, and these two electrodes are connected by a wire through a voltmeter. These two electrodes are connected by a wire through a voltmeter, and these two electrolyte solutions are connected by salt bridge. So how to construct this Daniell cell? It consists of two electrodes, zinc and copper. So zinc electrode dipped in zinc sulfate solution, copper electrode dipped in copper sulfate solution. And these two electrodes are connected by wire through a voltmeter. And these two half cells are connected by a salt bridge. So salt bridge is a inverted U-shaped tube. It containing saturated solution of KCl or ammonium nitrate in agar-agar gel. So what is the use of salt bridge in this galvanic cell or Daniell cell? It connects two half cells. Half cell means electrode. When we dip it in electrolyte solution, same electrolyte solution, that is one half cell. For example, here zinc rod, when it is dipped in zinc sulfate solution. So here zinc acts as anode. So that's why it acts as oxidation half cell. For example, here copper rod dipped in copper sulfate solution. So copper always acts as cathode, that means reduction. So that's why here this half cell is called reduction half cell. So these two half cells are connected by using salt bridge. So what is the use of salt bridge here? It maintains electrical neutrality in between two half cells. It maintains mainly electrical neutrality between two half cells. This is a construction of galvanic or Daniell cell. So already we know that salt bridge, it is a, how to construct this salt bridge? It is a inverted U-shaped tube. U-shaped glass tube. It containing saturated solution of some electrolyte solutions such as KCl or KNO3 or ammonium nitrate in agar-agar gel. So what is the main use of salt bridge? It maintains electrical neutrality in between two half cells. That means either oxidation of cell and reduction of cells. So what are the reactions takes place during in this galvanic cell? So for example, already we know that here zinc undergoes oxidation. So zinc undergoes oxidation, then gives zinc metal ions and loss of electrons. So and next cathode. At cathodic area, copper acts as cathode. At cathodic area, reduction reactions takes place. So copper undergoes reduction. Reduction means gain of electrons. That's why here it gain of 2 electrons, then deposit there as copper. So what is the overall reaction at cathodic in this electrochemical cell or Daniell cell? Zinc and copper, while it gives zinc metal ions and copper deposited there as cathode as copper. So how to represent this galvanic cell or Daniell cell? So here this is a representation of Daniell cell. Here zinc sulfate, that means it is a oxidation half cell. It is one oxidation half cell. And here copper sulfate and copper, it is a reduction half cell. So these two half cells are separated by two vertical lines, that is indicates salt bridge. This is a representation of galvanic cell. That means, for example, zinc electrode, when we dip in zinc sulfate solution, it undergoes oxidation. That means it gives zinc plus 2 ions. These two lines indicates salt bridge. And here copper 2 plus in copper. Why? Because here copper gain of electrons. Copper 2 plus gain of electrons. Why? Because it is acts as a cathode and deposited there as copper at cathodic area. So overall reaction in this Daniell cell is zinc plus copper 2 plus. It gives rise zinc 2 plus and copper. So this is a representation of galvanic cell. Now how to represent galvanic cell or electrochemical cell? It's also called a cell notation. So how to represent this galvanic cell? So already we know that this galvanic cell, it consists of two electrodes. One is anode and the one is cathode. So in this galvanic cell, for example, we are taking zinc acts as anode, copper acts as cathode. So this galvanic cell, it consists of two electrodes. Zinc acts as anode and copper acts as cathode. And the second point explain always anodic reactions written on left hand side. Always anodic reactions written on left hand side and cathodic reactions written on right hand side. And this electrode and electrolyte solution, for example, zinc acts as electrode where it is dipped in zinc sulfate solution. It is a oxidation half cell. This electrode and electrolyte solution separated by a vertical line. So it expresses oxidation half cell. That means electrode and electrolyte solution separated by a vertical line. It is called as oxidation half cell. For example, copper, where it is dipped in copper sulfate solution. So in this case, it is called as reduction half cell. So these two also separated by a vertical line. Next, this how two half cells are, oxidation half cell and reduction half cell. These two are separated by two parallel lines. Two parallel lines. This indicates salt bridge. And these two half cells are separated by two vertical lines. That is indicates salt bridge. Okay. So this is the representation of galvanic cell. So in this galvanic cell, how to represent galvanic cell? It consists of two electrodes. One is anode and the other one is cathode. So in this we are taking, for example, zinc acts as anode, copper acts as cathode. So always anodic reactions written on left hand side, cathodic reactions written on right hand side. And this anode, and that means here electrode and electrolyte solution separated by a vertical line. Okay. And these two half cells, oxidation half cell, reduction half cell, separated by two vertical lines, that is indicates salt bridge. So this is a representation of galvanic cell. So what is the use of salt bridge? Already we know that, just now we discussed, it maintains electrical neutrality between two half cells. This is a representation of galvanic cell. Now let's discuss cell EMF. So EMF abbreviation means electromotive force. So what is the meaning of EMF, electromotive force? The potential difference between two electrodes, or the potential difference between oxidation potential of the electrode and reduction potential of the electrode is called cell EMF. It is also defined as electromotive force. It is defined as the difference of potential which causes flow of current from one electrode of higher potential to the other electrode of lower potential. That means it explains the difference between two electrode potential, either oxidation potential of the electrode or reduction potential of the electrode. The difference is called cell EMF, or electromotive force. So how can we calculate this EMF of the cell? So here we are using one formula, E cell equal E RHS minus E LHS. E RHS minus E LHS. RHS means right hand side electrode. Just now we discussed always reduction reactions written on right hand side. Oxidation reactions written on left hand side. So that's why here right hand side, which electrode we are taking? Cathodic reactions. And left hand side we are taking anodic reaction. So what is the cell reaction? E cell equals E cathode minus E anode. Why? Because just now we discussed the representation of galvanic cell. Cathodic reactions are always written on right hand side. Oxidation reactions or anodic reactions written on left hand side. So in this way we have to calculate the EMF of the cell by using this formula. So here E cell equals E naught right. That means standard reduction. E naught indicates, E means single electrode potential. E naught means standard reduction potential. So how can we determine EMF of the cell? So standard reduction potential of right hand side electrode, that means cathode, minus standard reduction potential of left hand side electrode, that is anode. So by using this formula we can calculate EMF of the cell. So now let's discuss Nernst equation for EMF of the galvanic cell. So already we know that Daniell's cell or galvanic cell, it is represented as zinc electrode. When it is dipped in zinc sulfate solution, that means it undergoes oxidation. These two are separated by vertical line. That means it is a oxidation half cell. And these two parallel lines indicates that salt bridge. It maintains electrical neutrality between these two half cells. And next, copper. It acts as cathode. So during reduction reaction, that means copper gain of electrons when deposited there as copper. This is a reduction half cell. In this way, we can represent it is a representation of galvanic cell or Daniell cell or electrochemical cell. So what is the reactions takes place? Just now already we discussed. Zinc undergoes oxidation, then gives zinc plus 2, loss of 2 electrons. Okay, and at cathode, copper acts as cathode. So at cathodic area, reduction reactions takes place. So copper gain of 2 electrons, then deposited there as copper. So overall reaction is zinc copper 2 plus gives rise zinc 2 plus copper. This is the overall cell reaction takes place in this galvanic cell. Now discuss EMF of this cell. So already we know that E cell. How can we calculate the EMF of the cell? E equals or E cell equals E RHS minus E LHS. So right hand side electrode, that means cathode. So in this galvanic cell, copper acts as cathode. And in this left hand side, we are taking zinc acts as anode in this galvanic cell. So left hand side, we are taking zinc. So already we know that the nearest equation for reduction potential of copper, that is E copper equal, E means here single electrode potential. So the nearest equation applied for this reduction potential of copper. So what is the nearest equation for reduction potential of copper? E copper equal E Cu plus here standard electrode potential value of copper plus 0.0591 by 2 log copper 2 plus ions. This is equation number 2. Here E cell equal E copper minus E zinc. This is equation number 1. And when we apply nearest equation for reduction potential of copper, the value that is a E copper equal E naught copper. That means standard reduction potential of copper plus 0.0591 by 2 log copper 2 plus. This is the equation number 2. Now, nearest equation for reduction potential of zinc. So here E zinc equal E naught zinc. That means reduction potential of standard reduction potential of zinc plus 0.0591 by 2 log zinc plus 2 ion. This is the equation number 3. So this equation number 2 and 3 substitute in equation number 1. Finally we'll get E cell equal E copper 2 plus copper minus E zinc 2 plus by zinc plus 0.0591 by 2 log copper 2 plus by zinc 2 plus. This is the formula most important for numerical purpose. Calculate the E cell value. That purpose we are using most this formula. So in this way, by using this formula, we can calculate E cell of the galvanic cells or electrochemical cells. So now discuss what is the relation between, that means similarities between galvanic cell and electrolytic cell. Galvanic cell, already we know that this is the electrochemical cell. What are the similarities between electrochemical cell and electrolytic cell? Both are the cells, and redox reactions takes place in these cells. Redox reaction means both oxidation and reduction reactions takes place in these two cells, the electrochemical cell and electrolytic cell. And these both cells are contains anode and cathode. And oxidation takes place at anodic area, reduction reactions takes place at cathodic area. So these are the similarities between electrochemical cell and electrolytic cell. Now discuss what is the difference between electrochemical cell or galvanic cell or electrolytic cell. So already we know that electrochemical cell or galvanic cell means which converts chemical energy into electrical energy. But in this electrolytic cell, it converts electrical energy into chemical energy. This is the main difference between galvanic cell and electrolytic cell. And here in this galvanic cell, anode is negative. Anode is negative. But here electrolytic cell, anode is positive. And in this electrochemical cell, cathode is positive. But here cathode is negative. And spontaneous reactions occurs in this electrochemical cell. Here non-spontaneous reactions occurs in this electrolytic cell. And it requires in this galvanic cell, it requires salt bridge. But in this electrolytic cell, there is not required a salt bridge. And here does not require any external voltage source. But in this electrolytic cell, it requires external voltage source. So these are the differences between galvanic cell and electrolytic cell. Now we'll discuss few problems related to EMF. So what is the problem? Calculate the EMF of voltaic cell or electrochemical cell or Daniell cell. Here are given iron Fe2+ and copper 2+ copper. So here iron acts as anode, copper acts as cathode. Okay. So given the electrode potential of copper and iron are 0.34 volts and 0.44 volts respectively. So how can we determine E cell value or EMF of this galvanic cell or electrochemical cell? So just now we discussed already how can we calculate EMF of the cell. E cell equal E cathode minus E anode. That means E cell equal by using this formula E naught copper minus E naught iron. Here we are taking iron acts as anode. Before that we are taking zinc acts as anode. But in this problem we are taking iron acts as anode, copper acts as cathode. So by using this formula to calculate the EMF of the cell. So here copper electrode potential is 0.34 and iron electrode potential is 0.44. Substitute these values in this formula. You get E cell value finally 0.78 volts. In this way we have to calculate EMF of the cell. It is important numerical purpose. This formula is important. One more problem. How can you calculate the EMF of the cell if the reduction potential of the cell are minus 0.763 volts and 0.33 volts? So already we know that 0.763 zinc voltage E naught value. Copper 0.33 volts. Okay, so substitute in this formula, we'll get the E cell of the EMF of this electrochemical cell. Its value is 1.1 volts. So simply we says this formula is used for calculation of EMF of the cell. It's most used for EMF calculation purpose. And one of the model based on this galvanic cell. So in this problem, the standard reduction potentials of zinc 2+ by zinc and copper 2+ copper. These two are the oxidation of cell and reduction of cells. And these electrode potentials values are 0.76 volts and 0.34 volts respectively. So what is the EMF of the cell, zinc and copper? Already in this problem, they are given E naught values, also they are given concentration. So in this case, how can we calculate E cell value? So here, E naught value of zinc value is 0.76, E naught value of copper is 0.34. So by using, so how can we calculate E cell EMF of the cell? So E cell equals E naught cathode minus E naught anode. So substituting the zinc E naught value and copper value in this formula, finally you will get 1.1 volts. This is the EMF of given galvanic cell. So by using this form E cell, we can calculate E cell of the total cell of electrochemical cell or galvanic cell. For example, here E cell. What is the form? How can calculate if in case they given electrode potentials and concentrations of the solutions? In this way, we are using this formula. So what is the formula? E cell equal E naught cell minus 0.0591 by 2 log concentration of zinc by copper. So E naught value already we can calculate 1.1 volts minus 0.0591 by 2 log zinc. Zinc concentration is already given in this problem 0.05 m and by copper concentration is 0.005 m. So substituting these values in this formula, we will get 1.07 volts. This is another model of this galvanic cell. This formula is most important for numericals. So simply they are giving only electrode potential. In this case, we are using this formula. If in case they are giving electrode potentials and concentrations, in this case we are using this formula. It's most useful for calculation of EMF of the cell. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.